Jacob, welcome to Big Data Analytics. This is your autumn or fall semester class. The full name of the class, I guess, is Big Data Analytics, but I'll tell you why. It's the essence is about data analytics. The big data part is it's interesting, but we want go all out with the big data model. Anyway, okay. So welcome to the first class. I understand that most of you are in your second or third year, correct? Very good. And BuzzEye kind of separates into sort of like 3-4 concentration, right? Applied digital intelligence, smart city and inclusive community, sustainable development, and health and well-being. Now, the latter three, if you notice, are sort of like problems looking for solution, whereas applied digital intelligence more like solution looking for problems, right? But either way, you can't do one without the other. It's an integrated education. That's what the whole program of BuzzEye is. Actually, I don't need this one. We can right. So we meet every Tuesday afternoon. So very good. Appreciate you guys being on time, and let's keep that up. Now, as with most class, we try to follow what's called project-based learning. Now, right away, just make sure that we're on the same page. Project-based learning is not about learning how to do project, right? And that's sort of like I do project all my life, basically. I bring my knowledge, my expertise, and experience. I go to a client has a problem, has a data asset, and I try sort of like bring solution. Okay, you guys are trying to learn new things. Okay, the project-based or project activity is meant to be sort of like a way of engaging your activity, right? So you sort of like say, okay, what if I had a problem? What if this is the situation I'm trying to solve? What sort of technology would I need? And that will prompt you to explore area that you require. Okay, so it's not about applying what you know, because obviously that'd be no learning, right? Yeah, so very good. So today is an introductory class. In a way, it's probably very important that you pay quite a bit of attention, because this is how we set the tone and the expectation, as well as the basic understanding of what it is we're trying to approach. You hear things about machine learning, data analytics, data science, AI, all sort of stuff. Okay, and in fact, we're trying to develop a very clear curriculum set where you have a data analytics, you have machine learning, and also artificial intelligence. Actually, very separate discipline, interrelated but separate. Okay, so first, let's talk about what we are going to learn. Okay, what we're going to learn is really data analytics. Okay, data analytics. So let's go. I use mind map a lot. I try not to use PowerPoint. PowerPoint, by the way, I don't know if some of you may have heard me say this in orientation class. PowerPoint is very good. I use it all the time because it control and linearize the narrative. What it means is that I go to, let's say, a client, I do consultancy, right? So the first page is, there's a problem. The problems are very costly. You have that problem. The opportunity cost is high. Eventually, it leads to the final page, which is the technology that I can provide you is the best. Okay, so it's linearized the narrative. It's not very good for teaching class, and I'm trying to wean you guys off of PowerPoint-based learning. Okay, because life is not linear, neither is your knowledge. Okay, it's a bit more interactive. It forks out a different area. When I was your age, I walk into a class, and the professor or the lecturer typically would just come in with chalk in his hand, or maybe use a chalkboard and a book under his arm. Okay, most likely the book is written by him. Okay, and then he would just write everything from his memory or from his in-depth understanding of the topic. Okay, unfortunately, that means that you have to take your own notes, There's no handout, right? But that's exactly the best way to learn, I found out. Okay? So don't expect any handout from me. Okay? You should make your own handout. Make your own handout. Okay? So while I'm talking, you can, whatever, you can make little notes or however you like. Okay? Feel free to do that. Good. So what's data analysis? Well, let's expand that a little bit. Can you guys see? Okay. Yeah. Okay. Well, let's first go to what do you mean by data? Yeah. Now, I'm going to give this to you. You'll need Xmind download. I think we'll send you the link. You can use any mind map, but I use Xmind, so we might as well use the same thing. Mathematica is the software we'll be using. I'll tell you why. We will supplement it with Python for good reason, but you should have installed on your machine Wolfram Mathematica. Okay? Right. So what do you mean? What is data? Well, if you think about it, data, it always comes from some kind of measurement, some kind of record. Okay? It's record that pertains to some specific sample entities. But what it does is through the power of generalization, it allows you to make conclusion about the bigger population. Okay, so the first thing you have to understand is the difference between sample and population. Data is about sample. What you want from it is your insight about the bigger population. Okay, now, obviously, when I say sample population, you guys are sample, population is people your age. But your behavior today is also a sample. What is the bigger population? Your behavior tomorrow. Okay, so population is not always entity like a person, an individual, it's always over time. Okay, that's why when you study things like financial time series data, yeah, you get like price movement of some stocks or bonds over a period of 3 years. That's a sample. The population is all the past and the future evolution. Okay, so the wrong room. Okay. By the way, during the break time, we'll hand this out. You guys can write your name on this thingy and put on your desk. Okay. So it's general population, or in the case of time series, you can think of more general phenomenon. Price today is a sample of the population, which includes price yesterday, 10 years ago, and 10 years in the future. But you can think of that not as a population, you can think of that as phenomenon as well, right? Okay, that you want to analyze, okay? It's if you're just recording for prosperity, you don't want to analyze. So by definition, that's what it does. Okay. Now, when I wrote this, by the way, this thing hasn't been updated in a year or two, I think. In terms of how data comes in, okay? This is what made sense 2 years ago. 2 years ago. In other words, data comes in form of tabular data and whatever else. Okay? Now, tabular data, think of Excel. That's it. Just think of Excel. Okay? Basically, it has entries, right, for individual sample, and then you have whatever vector attribute it is. So student, height, age, I don't care. Okay? So think of it as a table. All right? Now, that for the longest time is the basis of data that business, commerce, government, judicial system, everything about human organization has been organized around this kind of data. Okay? And you can say that this has been since Sumerian time, like, 2,000, 3,000 years ago. So think of tabular data as table, as number 1 sample, 2, 3, 4, and then the first attribute, second attribute, third attribute, fourth attribute. Okay. Now pay attention. What kind of attribute can we put down? What kind of attribute can we put down? Okay. Again, this is something that's 90% of the application, and for 2 years ago, almost I can teach the entire class on nothing but tabular data. Okay, today things will be a little bit different. Okay, I've been teaching this class since 2020, and every year I've had to sort of like twist and turn things around a little bit because technology change, usage change. Okay, so it's not static. Right, but think of the Excel column. What can you put in a column? Well, obviously you can't put picture. Okay, well now you can, but back then you couldn't. You have to put something. You have to put something. Okay, most of the time you can't really put description. You only use description later. But most of the time, really, think about numerical things that you can represent, things that you can record in traditional spreadsheet. Well, I maintain that we'll try to do this. We'll separate into, well, you can see. Okay? First is sort of like descriptive, categorical. Describe something about this sample. That's opposed to the other sample. Okay. The other one is more quantitative, numerical. Okay. So make that mental distinction. By the way, mind map here is meant to be give a sort of like a picture in your mind that there's a distinct forking. Okay. So something about you. You know, you're tall. You have dark hair. You have I don't know, big ears, small ears, or something like that, right? So these are kind of like characteristic. But if I distill it down to actually, well, how big of an ear, you know, how big is your pupil size or something, that becomes more numerical. Okay. Well, let's separate that further. Okay. Let's separate that. I'm going to talk in terms of what's called numerical scale. And this is very important. And this is like, you know, we're only 5 minutes into this class. So it's actually very elementary. But believe it or not, you know, I've only been, you know, full-time faculty for 2 years. I've been spend my time mostly in banking, right? Professional data scientists make silly mistakes simply because they're not cognizant or they're not aware or they're not mindful of the type of data they're working with. And basically what they're doing is they're mixing these 4 categories. So even though this is simple baby stuff, and some of you may have seen this, it turns out to be very costly in application when people try to build machine learning, assuming it's one scale when it's the other. Okay, so let's run through them real quick. First, what's nominal scale? So what I'm trying to say here is data here is represented as number. But the number is not just counting 1, 2, 3, 4, 5. It's measurement against some kind of scale. So we have to think of what do we mean by scale. Okay? Now, nominal scale, what does that mean? Nominal scale just means that it's a scale to represent names. So your student ID, for example, belongs to nominal scale. Okay? Mathematically, what can you do with it? You can only check if it's the same. Okay? There's actually like a different math worksheet I can show you. But the mathematical operation you are allowed to do is equality and not equality. That's it. That's it. Yeah. So you can't say that because your student ID is higher than the other one, you're a better student. Can't. So that's number 1. Okay. Second is ordinal scale. Just mean order. Okay. The most useful example is beauty pageant, right? You have Miss Universe, first runner-up, second runner-up, third runner-up. What operation can you do? Greater than, less than, greater than, equal, not, right? But can you say something like this? The distance of beauty between Miss Universe and the first runner-up versus distance in beauty between the first runner-up and second runner-up. Can you do that? Makes no sense. So all you can do is order stuff. Okay. Now these tools are sort of like categorical kind of number. So if I say 1, 2, 3, 4, 5, A, B, C, D, E, right? A is better than B, B is better than C, but I can't say how much better A student is to B student. Now you'll say that actually, wait a minute, there's a raw scale, right? There's a raw score underneath, right? That comes later. Okay. So let's go to the next one. The next one is interval scale. This is where you can have interval. Interval means space between, right? So I can say this room is 25 degrees Celsius. The other room is 38. So what's the temperature difference? I can take subtraction, right? But I could not have taken the subtraction between the beauty of the first runner-up and the fifth runner-up. It makes no sense. Absolutely make no sense. By the way, this is the thing I was talking about. A lot of data scientists would make what's called interval conclusion, like a distance based on ordinal number. And this is where, like I said, I've been a professional for in my professional life, this is the silly mistake that, very competent programmer, even knows how to use advanced machine learning code, make a mistake on. Just make a conclusion based on this. Yeah. Somebody's 2 steps above as opposed to 1 step above, that sort of thing. Okay. Sometimes the consequence is serious, sometimes not. Anyway, finally, well, can I say that if this room is 25 degrees Celsius, the other room is 50 degrees Celsius, can I say that it's twice as hot? No. Why? Because if I transfer the unit into Fahrenheit, it's no longer 2 to 1, right? Right? 50, twice as big as 25. But 50 times 9/5 plus 32 is not twice as big as 25 times 9/5 plus 32, because there's no absolute zero, right? So what you cannot do? You cannot divide. You cannot make ratio. Finally, the most information rich is ratio scale. Yeah. So right there, keep this in mind. It's very easy, right? It's maybe you can teach this to a 10-year-old, but if you're not mindful of this, you will build a machine learning model based on ordinal scale target, make conclusion to your clients with interval scale conclusion. And it will be terrible for business or bad for your reputation if you do this. Okay, so keep this in mind. This is one of those things where it's simple, but be mindful. Anyway, so now look at this. So now I say tabular, right? And then I said etc. Okay, this is where you move from traditional data to big data. Okay, I'll give you a definition of big data later. But one of the first elements of big data is that it comes in non-numerical form. It comes in different style. It comes in different format. So instead of being able to store like a number in a spreadsheet, it's now a picture file. It's an audio file. It's a text. It's a paragraph. It's a picture. I already said picture. Video. It's sound, right? It's chemical composition. So this is where the world gets bigger in terms of, analytics. So when I was your age, if you knew so much about tabular data, numerical, as long as you do these 4 things, you go good. Okay? Not anymore. Not anymore. Okay? Now you have to learn a lot more. Then you can ask me, in my opinion, say my professional experience, what next? What are the things? Well, this is where you can think of more general or specific answer. A specific answer is, what are you working on? If you're going to work in song, well, certainly audio file is the data that you're going to work with, right? If you're going to work in genetics engineering, then certainly chemical bond and protein sequence, that sort of thing, that's the sort of thing you work with. Okay, so those are specific. But I maintain that in your generation, just as in my generation, tabular is the king, and it still is king. Okay, but now you have to think of the queen and the prince. Okay, the queen and the prince of the data type of data are 2 things. 1, text. 2, graph. Now, when I say graph, you're going to think of plotting a graph. No, I'm not thinking of that. What you should think about is what people call network. Okay, now think about this. Think about this, right? Let's take you, right? You're the first sample. You have a height, that's a number, right? You have a weight, that's a number. You have degree, right? And so forth. You have a grade, okay? So these are something that goes this way, right? How is it indexed? It's indexed by you. In other words, it's height underscore, let's say your name, what's your name? Pitapong. Pisitpong. So it's height underscore Pisitpong. Weight Pisitpong, right? Okay, there's only one index. Graph or network is indexed by two identity. So if I ask, who are you friend with? What's your name? Severe. Severe, okay? So there's a friendship between Pisitpong, comma, Severe, right? So I, comma, J. The essence here is the connection. Now, this connection can have any kind of number scale. It could be, yes, do you know him? No, do you know him? In which case, it's 1, 0, right? It could be, well, it could be interval scale even. It could be ratio scale. For example, how many years do you know each other? Right? 7.9 years. So the link between you two is 7.9. The link between you and you is 5.8. I can ask question like, how many times is 7.9 longer than 5.8? I can divide, right? So that link is ratio scale. Okay. So it could, same thing we could do. The point is now you can't just index once. You have to have two index. That in mathematics is called a graph. Okay. So when I say graph, the colloquial or sort of like popular word for it is network. Okay. But it's called graph. So just as you have tabular data being the bulk of the database, you are going to, in your generation, have two more huge class of data that you're going to have to deal with. One is text, and one is graph. Okay, so bear that in mind. So right away, from the very first day, you haven't touched a computer, you haven't even key anything in data structure. You're already learning that how the world of data has changed. Okay. In fact, I do a lot of graph, and when we have time, we'll discuss a little bit later about my earlier experience with graph database. So now you have even people trying to build a database based on graph, like Neo4j or something like that. But you don't have to worry about that. Okay, so definition again. Data is about some kind of measurement, right? Quantifiable or recordable about something specific. But that is not something you're interested in. You're interested in a bigger representation. I like to give an example that, if you know what your mom likes for breakfast, that's not data. That's just your mom. Okay? When would this be a data? If what your mom likes for breakfast represent what women her age likes for breakfast. Okay? So that would be generalization to women her age. What else can you do? If your mom likes that for breakfast, it can be generalized to your mom tomorrow morning. Now you can do that, right? But if it's just your mom likes for that breakfast morning and it's not generalizable, it's not a sample of a population, it's not an evidence of a phenomenon, it's not data. Okay, it's just memoir. Okay, so data is something that, yes, you record just like memoir, but you're not just doing it for fun. You're doing because you want to make some kind of generalization. Yeah. You want to, but you don't know how to. That's what analytics is. Okay. The whole thing about data and analytics, first of all, data has to have some kind of, it has to be based on some kind of population that has some kind of consistency, right? If you're trying to model how what your mom likes for breakfast, and she's like completely unpredictable, then that data is worthless. But if your mom is somewhat predictable, so if you say, oh, she tends to like eggs on weekdays and muffins on weekend or something like that, and it has a degree of generalizability, yes, that becomes data. What is your analytics? Your analytics is if in the past on weekdays she has a probability 0.8 or 8 out of 10 she eats egg, and on weekend 9 out of 10 she prefers muffin, then using that to make a prediction, that's your analytics. Yeah, so you can see why my emphasis is on data analytics. The big data just come from the fact that beyond tabular data, you're working with many other kind of data, and they're also huge and comes to you quick, thick, and fast. Okay, let's do that. Okay, so population. I'm going to skip some of this. This is just right. So let's talk about big data. So now, by definition, big data has over and above traditional data is what's called 3V, and you may have heard this in popular usage. One is velocity. Velocity means it comes to you quick and fast. So for example, an app, if I'm going to keep a record of my clients, in the old days, I just have, name, address, and bank account, and every time it moves, maybe that's that. But now, every time my client goes into an app, I can actually log in his behavior. What's he looking at, right? Is he checking out his saving account? Or maybe if he's checking out saving account and the amount is a lot, maybe I can sell him investment products, right? Because it's no use having a saving account really big when it could be earning interest from buying bonds or investment into a portfolio type investment, right? So information come quick, right? Quick. And the volume, well, of course, volume is huge too, because I'm not just storing how much money he has with the bank, but what activities, how many pages he visit, what pages he visits. So volume is huge. And finally, the variety. And that's the one that I was talking about earlier. Okay. Now, technically, you can group things into, beside text, you can have things like multimedia, you can have network and protocol, there are all kind of stuff. And this is just a example. Okay, so that's it. So that's all you need to know, I guess, for now about data. So I'm gonna that. I'd like to share with you this thing, but I would actually prefer to update it a little bit. So this to me is outdated. Okay, now. Okay, let's do this. First of all, what's analytics? By the way, analytics is a bit of a new word. In the old days, you would use the word like analysis or analytical tools, right? So analytics, basically, think of it as a toolbox. Notice analytics always has an S at the end. It's always multiple, okay? It's not one tool. This is very important, not just in terms of linguistic, but it marks a change in the way people work. You used to have, let's say you want to make prediction, right? Future as a function of the past. You only had one tool called regression equation, let's say, okay? That's the sort of thing. So you have one tool. So you're not carrying around a bag of tools. But your problem will change, your X will change, your Y will change. But essentially, you can only do one thing. Y is equal to A1, A0 plus A1, X1 plus A2, X2 plus A3, X3, right? Now, a bit more fancy, you can have, non-linear regression. Fine, that's very interesting. You can do all kinds of stuff. But essentially, you have one tool, quote unquote. Okay? So analytics, think of it as a toolbox. Okay, have you seen those handyman who fix things around the house, right? It doesn't come with just a hammer. Comes with hammer and screwdriver, and swans, and all kind of stuff, all kind of swingy thing and clamping thing and all kind of stuff. So think of it as a toolbox, a suite of tools. Yeah? Suite of tools. Now, that suite of tools will be different for different jobs. Just like in the toolbox, right? Sometimes you want to open it, sometimes you want to break in, you use hammer, you cut things, you use scissors. So the tools are different jobs. But even tools that are doing essentially the same job can come in many forms. For example, a knife cuts, so does a pair of scissors. But one is better than the other for some situation, right? So I don't bring a cutting tool. So even for the same job, I'm bringing a knife and a pair of scissors. Likewise, I'm not just bringing regression equation. I'm also bringing neural network. Maybe I'm bringing support vector machine. Maybe I'm bringing decision tree. Okay? And they kind of function the same thing, just like scissors and knife, but done differently. And definitely, you can say that one is better than the other. Most of the time, you can say, not beforehand. The difference between a handyman and data scientist is, okay? And pay attention to this, it's very important. A handyman can look at a job and say, scissors is better than knives, right? A data scientist cannot. Because what works best is the result of scientific experiment. Okay? So in my professional life, I've done this. Again, I've spent most of my time in a bank. I need to basically predict Y from X. Okay? Predict Y from X. I could not, like a handyman, say, for this job, I'm going to use neural network. I could not do that. Because whether or not neural network works better than simple linear regression, logistic regression, okay, all kind of stuff, all kind of tools, is a function of experiment. Because until I try that, this is something new. Now, once I've done it, it becomes a scientific knowledge that this data works best with this model. And so when the new data comes in, I can use that. Okay? Just like in medicine, you study first what drugs work with what disease. And when a new patient comes in, once you made that conclusion, you can generalize, say, okay, well, same disease, so same drug should work. Okay? Now, occasionally it won't work, and then you have to find out, hey, what's the difference, that sort of thing. But essentially, that's the difference between a handyman and a data scientist. A handyman is not a scientist. Okay? He's a technician. He knows his stuff. A scientist does not know. Okay? A scientist has to form a hypothesis. So it's not complete guesswork. I do have a hypothesis that for this data set, nonlinear regression will probably work better than linear regression. Okay? Or tree-based decision tree probably works better than numerical method, other numerical method. So I do have a little bit of hypothesis, but until I test it, no idea. No, well, can't make definite conclusion. Okay? So again, today's quite relaxed. It's all insights. Okay? You don't have to, be tested or do anything, but pay good attention and make your mind an intellectually absorbent medium. Okay? That's his job for today. Yeah. So problem, all kind of stuff. Well, you learn all this. Now, there's a whole bunch of steps into getting the job done and so forth. So let's talk about this. So first thing you have to do is a model. Basically, a model is what hooks different things together. Hooks variable. Y, model as a function of X. X is model as a function of X. X yesterday is model as a function of X the day before, whatever, okay? So model is, in our class, ultimately mathematical, okay? Now, how you build it may not be mathematical. You use machine learning tools, right? Machine learning tools use computer codes. But what computer codes implements is mathematics, okay? So at the end of the day, it's all about, well, apply math, basically, right? Why do I say that? Why do I say that? Why do I say that? You guys ever thought about that? Why do I say that at the end of the day, it's apply math? Because, think about it. Let's say, okay, I'll give you a good example, right? Y is equal to 3x. What am I saying? That based on what I know, I can give you value of y every time you give me a value of x with certainty, okay? And this will work for the rest of eternity. Okay. Now, that's what you learn in grade school, right? The data analytics works like this. You get a bunch of x and accompanying y, okay? And again, based on experiment, you think that you can predict y as a function of x by y is equal to ax. And then, based on that sample of x and y, you determine that a is equal to 3. So when the new x comes in, your guess for the best new y is 3 times that x. Okay? So at the end of the day, you have mathematical equation. Equation is what links the left-hand side with the right-hand side. Now, traditionally, the right-hand side is what you know. The left-hand side is what you want. So you put x on the right-hand side because you know. You multiply by 3 because what you want is 3x, which is your estimate of y on the left-hand side. This is just, you can go 3x equal to y, but, everybody's right-handed. So right, y equal to x. What I want is equal to what I know and the model. The model is multiplication by 3. What I know is value of x. Okay? I don't care if you're going to the most advanced generative AI. At the end of the day, it's about converting data into some numerical form that gets inside a computer, that goes through a function, that gets its output, and that output gets interpreted by you. Okay? So everything from y equal to 3x to ChatGPT is based on this principle. And ChatGPT doesn't take text, guys. Okay? You key in the text, but somewhere along the line, ChatGPT takes this as numbers. And you learn about it. Okay? So it's all applied math. It's all applied math. Huh? So just like, how are you? And ChatGPT say, fine. How you are, whatever. That I'm fine, thank you. That's Y. How are you? That's X. And that X doesn't get processed by ChatGPT as text. It gets processed by ChatGPT as number. There's we'll talk about it. So at the end of the day, it's all applied math. Okay? Now, what's the difference between math and model? Well, model is a broader sense. It's a representation of nature. It's a representation of nature that you can play with without killing anyone. Okay? So, if I'm going to be a medical doctor, I want to practice, I don't know, operating on someone's heart. Okay? And I operate on live patient. Okay? Chances are I'm going to kill a lot more before I start saving life, right? So what do? They make a little model of a human heart. So I can play with it all I like. Okay? It's realistic enough, but it's not as costly. Okay? Now, if you're talking about physical model, that's what it means. A mathematical model just simply say, okay, let's put it this way. Here's a reality. For every 3 pig you see 5 horse. Okay? That's reality. 3 pigs, 5 horse. Mathematically, you make a mathematical model, you say X and Y is 5/5 of X, right? So every time number of pigs come in, you multiply by 5, divide by 3, you get number of horse, okay? So mathematical model doesn't represent other essence. It only represents quantitative relationship. Yeah. So that's it. So what we deal with would be mathematical model, because mathematical model links X and Y. But if you did that, you're just learning mathematics. You're learning data analytics, so that instead of learning Y is a function of X, you say, how many ways can Y depends on X? And if I have a whole bunch of X, I have a whole bunch of Y, what kind of function should I consider? Okay, in this case, Y is equal to AX. And if that's the case, what is A? That's estimation, right? Except you don't just have Y equal to AX, you have Y equal to AX squared plus log of X, Y equal to X cubed minus logistic function of X. You know, you have a whole bunch of things. That's why it's analytics with an S, right? Yeah. So what do you think you should learn? If you learn just one thing like regression, and I bring you a whole bunch of data, are you learning data analytics? No, right? If I bring you one set of data, I bring you a bunch of tools, scissors and knives and so forth, is that data analytics? Also no, right? So it's multiplicity of everything. It's multiplicity of tools, multiplicity of data. Okay? But one thing is the same, the principle that your data is a sample representing a phenomenon or a larger population. You're trying to make mathematical model that represents quantitative relationship that you can see from the data, and then assume that the world tomorrow is the same world we live in today. So when you get a new X, you know what to do with it. That's it. That's the end of story. Okay. Now, as you go on further for machine learning, artificial intelligence, you will see that there are machine learning tools used for data analytics. There are also artificial intelligence tools used for data analytics. But know this, that's not all. Artificial intelligence is more than just solving data analytics. Okay? Same thing with machine learning. Okay. Where are we? Okay. Dimutu, I have to rely on you to sort of like give me a signal when we're kind of halfway, because I tend to forget. Right. So this is kind of now. So here's the deal. Let me let me flip you to this class description. Okay. So now you have a basic idea of what data analytics is all about. By the way, I'm sort of like we're in the process of overhauling the curriculum for Basai, and the class description will tend to be uniform in the sense that you should expect 3 sentences. Okay. The first sentence is the subject matter. What's this class all about? Second subject is teaching modality. How am I going to bring you to this? Most of the time it's project-based learning, sometimes it's theoretical or whatever. And finally, it's learning outcome. And that's very important. Okay. Learning outcome focus on you, what you get out of this course rather than what I put in. Okay. So you will see that course description here has also 3 sentences. So what's the read, you don't have to read out loud. This course introduces you to the principle and practice. Principle and practice, not nitty-gritty individual project. Principle and practice of data analytics. Data analytics is a suite of tools based on data science and quantitative analysis. What does it do? Well, it helps business and enterprise do things. What does it do? It mines data for information, transform information into insights, and then leverage insight into better decision making. So the last part is where it makes money, basically, right? So that's why they use the word data mining. The reason they use the word data mining is because it's like mining for raw material. It's something valuable there, but it's hidden, right? It's hidden. It's not in the final form. So you have to mine it, just like you mine for iron ore or diamond or oil or whatever, right? But how many of you actually fill up your car with crude oil, right? And when you want to buy your girlfriend nice diamond, it doesn't come into a little lump, which is what you find in nature. It's nicely cut, right? You also don't put crude oil in your car because it has to be refined. Okay, that's the bit we're doing. So data, you have to believe. First of all, when I go to a project, I have to evaluate. The client has to evaluate my capability. I also have to evaluate the client's data asset. They have to have data that contains insight. Okay, but right now they can't make any head or tail out of it. But I look at it and say, oh, you know what? They collect data about the engagement from client from 5 years ago. Okay. They collect data about their whatever campaign response. Oh, okay. So chances are there's something valuable in there. Mine it for information. Information comes in the form of the conclusion from the analytics. And then the final bit, this leveraging insight into better decision making. Most of the time, it's not my job. Okay, most of the time, for example, if I say, for example, like for my bank, I'd say discover that clients who use this transaction in the beginning of the month tend to also use it for other kind of transaction on the 3rd week of the month. How they make money out of it, that's not my problem anymore. Okay, it becomes marketing teams, whatever. Okay, so basically, even though it's actually three stages: mine data for information, transform information to insight, leverage insight for better decision making. The last part usually is not our job. Okay, so usually not our job. If you did the first, sometime you did the first 2 part right, it's almost obvious what to do. Okay. And you see that a lot with things like bundling, purchase, and all kind of stuff. Anyway, so second statement. So that's what it's all about. Second statement, what's the learning modality, teaching modality? How am I going to teach you? Well, because this is not simple, addition, you're going to have to learn the basic, how things work, how the mathematical model works. So I have to mix with, mathematical theoretical foundation of how things work. I call it under the hood. Okay, call it under the hood thing, right? So how this thing works under the hood, and then you will have some experience with computer coding. Okay, computer coding. How many of you have taken, for example, Python or R programming in your first year? Okay, right. I'm going to do one, but I'll teach you Wolfram Mathematica, which I'll tell you why later, but you will be interspersed with Python thing as well. Finally, what's the outcome? Well, you should have a good understanding of how, data analytics really work. And sort of like get a glimpse of what professional people do. Now, this is very important. And I'll give you one glimpse right now. You anticipate data scientists would go in there, take the data, do all kind of like, high power model. I'll tell you what professional data scientists do. They spend 80% of their project cleaning data. And that's how things work right now. Now, in the future, life may be a little bit different, but the exciting bit is only 20%. Okay. So it's like you're learning to be a surgeon, but you spend most of your time sharpening the knives or something like that. I don't know, or cleaning the wound. It's a bit like that. Okay. Now this is not bad. Okay. Um, as you rise up, you become more value for your knowledge, your expertise. Then you start having younger people, less expensive data scientists do the cleaning stuff for you. Okay. But in the beginning, that's what you do. Okay. You get your hands dirty, which is okay. It's actually good. It's actually good. Okay. It gets you to have a good intuition about what your data is all about. I don't recommend you skipping over these steps. Okay. I don't recommend you over these steps. So, and now also, how you would, how professional data scientists would sort of like go to a site and start from the beginning, assessing what kind of data asset it has, formulate the problem, plan the strategy, like how am I going to tackle this? What kind of data experiment I'm going to perform? Really, when I do consultancy, I design experiments. This is kind of weird, right? You think that when I go consultancy, I'm so smart, right? I'm so smart. I see the problem, I give the solution. That's not the data science solution. Data science solutions say, I look at this set of data, I pick a collection of tools that ought to work, and I throw them at him. And whatever came out on top, that's the best solution. Okay. I could not have a prejudge. I can have a bet. I can have a bet that, if I use this tool, support vector machine, ensemble learning, gradient boosting, my guess is this might work. I can bet just for fun, right? But that's not a professional responsibility. Professional responsibility is actually experiment. So when I solve problem for clients, a lot of time I'm actually setting up scientific experiment, data scientific experiment. And based on that conclusion, I tell them what works best, and that becomes a representation of the data. And then they can use that for insight, they can turn that to making money or whatever. Right. So you have some kind of coding, hopefully you have some kind of coding skill and experience from this. And then, the key word is what's called pipeline. How you build from beginning to end, from data, cleaning, munging, format, all the way to presentation. Okay. So in terms of outlook, again, put yourself in the mind, professional data scientist, that's your outcome. Yeah, you should be able to understand. So basically, just expands that. Okay. Now, the outline here might change a little bit. I tend to sort of like remain flexible. So these are kind of like baseline. Don't say that you learn all this, you pass the course, because chances are maybe I'll just put these two things together in 1 week and make a room for something else. Okay. But this is sort of like a baseline. This is if something should happen to me, somebody take over the course and they can follow this and fulfill the basic. Okay. But not so serious. But basically, what's it all about is at some point, it's going to involve machine learning and statistical tools and visualization. So let's go back to what it means by data analytics. Right? So data analytics here is, well, you have the problem, yeah, you have the data, yeah, and you apply some models to it, right? You experiment, and then you get result. You apply. So I can go into details. We have time, but what I want to do, first of all, is not first of all, before we go to a break, is to say that the three key elements we have, three family, if you will, three family of data analytics would be, one is visualization, because it turns out that sometimes just visualizing the data speeds you right through to the end. You get the insight, you know how to leverage for better decision making without making y equal to f of x. Okay, just by having a good plot, right? It's sort of like somebody's bleeding from a battlefield or something, right? So the big thing is not the mystery of what kind of the disease that is. It's probably bullet wounds. The most important thing is to know where the bullet is, right? So if you get a clearer picture, where's the bullet wound? You don't have to, that's it. That's it. So sometimes data is like that. If you visualize it in the right dimension, in the right tool, your job is almost done. So data visualization is very important. Yeah, so that's one family. The other family is statistical model. So these are things that I think some of you have learned in high school, some of you in the first year. So these are like traditional mathematical model, okay, used for numerical data. And most of the time, this would work very well if your x and y belongs to either interval or ratio scale. Okay, but if your data belongs to nominal scale, ordinal scale, sometimes doesn't work so well. Okay, but the good thing with statistical tool is that they have built this up for 300 years. Okay, so it's well established. And then finally, the other family is based on machine learning. And this is where you get a lot of time confused with AI as well. Sometimes it's derived from AI, sometimes it's not derived from AI. Okay, but how we use it is what's called machine learning. The difference is, remember, I told you that you have data and you have to choose f of x and then estimate, right? So if I decide that y is equal to ax and then estimate the a, well, statistic is a bit like that. You have fixed form of function and then you just estimate the coefficient. With machine learning, you are more flexible. Okay, so you don't have a fixed form y is equal to ax, a1 x1 plus a2 x2 plus a3 x3. You don't have that kind of fixed form. It's more open. Okay, you still have to do estimation. At the end of the day, you come down to mathematics, but you don't have this fixed picture. Okay, which is good and bad. Good is it's more powerful. Bad is because it's hard to explain, right? If I say y is equal to 3x, okay, it's very easy to explain, right? For every x, you get 3 of y or something like that, right? It's a lot nicer. So I guess if you talk about visualization, clear as day. Statistics, it's still not as clear as day as visualization, but still it's a very clear picture. It looks very clear. Y is equal to ax, that sort of thing. And you just estimate the a until you are happy. When you go to machine learning, you get y is equal to some function of x, but you can't really sort of like write down exactly what that function is. Okay, so it's not as transparent. But just as this is clear, this is less clear, this is not clear, this is least powerful, this is more powerful, this is most powerful. Okay, so that's that. So I give you that perspective, and maybe that's a good break point, or no?